How do we measure it? Now, I wanted to give you this for, this won't take me long. It's only one board here, and then I got a little video clip for you. Again, I just wanted to show you this because I noticed as I was getting your papers back from the accidents that you were getting tons of different types of radiation, Curies, REMs, RADs, one I didn't even recognize, Sieverts. I mean, there's what?
The PBQ.
Yeah, I think that's probably equivalents and stuff like that. I honestly, there's so many different ways you can measure it. It's one of the problems with radiation. It becomes very confusing to understand how much radiation was actually given off, unless you have a knowledge of what these words mean, these units mean. So I want to talk about the different ways we can measure radiation. Okay, and we'll start with, well, obviously with the Geiger counter, which basically a real Geiger counter contains argon gas. And by the way, I actually have an old civil defense one, I think, in the back here. So I'm sure it doesn't work anymore. And it's ionized when exposed to radiation, and therefore it can conduct current. So the more current you conduct, the more radiation, that ionize that argon gas. Oops. Here's an old one, I think. Yeah, check this out. Like from the 1950s. Check that out. Isn't that cool? Wow. It's got this little thing here you point at the source, and then it reads here what the radiation is like. And basically, you could tell how much radiation is given off because that gas that's in the container is ionized when exposed to this. To radiation, to ionizing radiation. That's kind of cool. If you ever watch an old sci-fi movie from the 50s or 60s, well, everything was radiation back then. Like giant ants, giant grasshoppers. They ran out of giant people, the attack of the giant woman, the giant man, colossal man. All of that was from radiation. And you'll see somebody holding one of these things. All right, about radiation. It's pretty cool. Anyway, that's how you measure it. Now, you actually have quite a few units that get confusing. All right, let's start with a Curie. Named for who? Madame Curie. Who? Yeah, you're right. Curies are named for Madame Curie, Marie Curie, which I always was proud of. Maybe she's proud of her because she's a woman, but I was always proud of her because you think she's French. Madame Curie, and she married a Frenchman named Curie, but her actual name was Polish. She's Polish, and I'm Polish, so I was kind of proud of that. Anyway, a Curie, by the way, she was the first woman to, not to exist, that would be Eve, the first woman to actually get the Nobel Peace Prize. Nobel Prize in science, not Peace Prize, Nobel Prize in science. First woman to get that. How about that? And she did it with her work on radiation, radium. She ended up dying from it too. Because at the time, they didn't know how dangerous radiation was. They were actually able to find, I don't know if this is an urban legend or not, but from what I understand, they were able to find her grave with a Geiger counter. That's how radioactive her actual body still was. Now, again, that could be one of those urban legends. I should probably look it up and see before I tell you that. But I did hear that. That's how badly contaminated her body was from all her work with radium and radiation. Okay. What is a Curie? Well, that's the person. Let's talk about the actual measurement. Well, Curies are measuring basically the radioactive decay activity, but not anything else. Just how much radioactive decay is going to be going on here. All right. So when you looked up numbers and saw, for like Chernobyl, for example, that more Curies of radiation were given off than in Nagasaki and Hiroshima combined times 100 or times 1,000. It seemed a little hard to believe because you're thinking to yourself, well, how did, that Nagasaki and Hiroshima killed like a couple 100,000 people. Why did only 50-some people die from the initial blast there at in Chernobyl, and maybe a couple thousand afterwards? Well, because this is not that useful a measurement. Yes, that much radiation was released, a lot more radiation even than in an atomic bomb. However, there's a lot of other relevant factors. Yeah, we dropped that bomb to kill people. We dropped it in the middle of a city, all right, to kill people. So the proximity, how close it was, the types of radiation that was given off, the length of exposure, all right, all of that, and how much was given off all at once versus the fact that Chernobyl, for example, burned for days, releasing all that radiation, and it's still releasing radiation, all right, even in its sarcophagus. They've made it, just not like it was before. It's not really to this point. At this point, it's very dangerous as long as you don't get too close to it. All right, so this isn't very useful for determining how it's going to affect you and your health. Rankine goes a little bit further. It's a little bit more useful a term, a Rankine. It measures the radiation exposure in the air, but not necessarily how much was absorbed. A Rankine. It's pronounced Rankine. So how much gamma or X-ray radiation one might be exposed to, but not necessarily absorbed. The reason I'm going through all this is, you see, as we get down to each of these measurements, each one is applying more and more and more to humans, to like what we are concerned about, our health effects. Okay? Just because there's that much radiation out there, you know, doesn't mean that's how much you're actually being exposed to. Like, for example, the sun gives off, I'm sure you could probably calculate, somebody probably has calculated how much radiation is given off by the sun. How much of that, yeah, lots, exactly. How much of that actually hits the Earth? Well, considering how far away the sun is, and, you know, obviously not very much of it. A very, 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 very tiny percentage actually is going to hit the Earth. The same is true for Curie's. Rankine's a little bit better. That's how much is in the air. A RAD, a radiation absorbed dose, is a little bit closer to a more useful measurement as well. It measures the amount of radiation deposited in a material.
Why do you, in number 2, why do you have start parentheses?
Oh, I should have ended them there. Okay? So this measures the amount of radiation actually deposited. So now it's not just how much was out there, all right, or available to be deposited, but how much was actually deposited in a material. And finally, you've got a REM, which is what we usually, and I know at the power plant, I'm pretty sure at the power plant, again, there are other units used, but I'm pretty sure they use REMs or millirems most of the time. And you did see that one a lot when you were doing your 3 Mile Island research. You know, how many REMs or millirems were people exposed to in the town. Okay, and I think it was on the order of like 6 millirems, which is a very small amount. Okay, that was how much was given, the average. Okay, and of course REM is a band, but it stands for Rankine equivalent man. Also stands for rapid eye movement, which is what you go during rapid eye REM sleep. Yeah, for during dream sleep. Yeah. You ever heard that? When you're dreaming. You never heard that? Seriously. Yeah. Nobody's heard that, REM.
Wait, can I tell about a dream I had one time?
It depends.
No, it's really good.
Okay, quickly.
So I had a dream that I lived with all of my teachers, and Mr. Wolf came to wake me up, and he's like, Marie, it's 6:15. You gotta get up. You're gonna sleep through your alarm again. And I was like, oh, thanks, Mr. Wolf. So I get out of my bed, and I walk into the hallway, and Mrs. Phillips comes running from her and Mr. Phillips' room. She comes running over. She's like, Marie, the oven is still hot. Don't touch the oven. And I was like, oh, thanks, Mrs. Phillips. So I went downstairs, and I did not touch the oven.
Excellent. So Mrs. Phillips saved your life, if you want to say that. There you go. That was a nice dream.
That's going to win an Oscar one.
Olivia came, and she thinks that's what we do. We talk about we interpret dreams in here.
Selling the gravy rice. Story all the time.
And they never, do they always have this point? They have to have a point.
She got radiation from the oven.
All right. All right, so anyway. A REM, or a Rankine equivalent man, is a very useful unit, and it is used at the power plant, and you have little dosimeters that you wear if you go up there that basically tell you how many REMs you've been exposed to. It's a standard unit used to measure the dose from radiation that was absorbed in human tissue. Okay? And that's a very useful number because I could actually, I know, could actually tell you how many REMs or millirems you basically are exposed to in a given place, a given year.
Oh, yeah.
360 milligrams is the average amount you would get from natural, and by the way, 3/4 of that is from natural sources. Now, you can get a lot more based on where you live, believe it or not. If you live, for example, in the Rocky Mountains, which are just naturally radioactive, a lot of radioactive isotopes in those rocks, you'll get about twice the background radiation that you would get from living here. But there are places in Pennsylvania where you'll get 2 or 3 or even 4 or 5 times the amount of natural background radiation if you're not careful, because you may live above an old mine, a vein where they mine uranium, and maybe there's radon in your basement from the decay. And so basically, depending on where you live and what you do maybe for a living, you might get more radiation than that, but that's about the average. And again, if you haven't learned anything from the previous couple of classes I've talked to you, your own little research maybe that you've done, we are a little bit overly scared of radiation than maybe we should be, because you're constantly being bombarded with radioactive stuff, rays and particles all the time. From the sun, from the ground, from pretty much from the water. I mean, it's seriously everywhere. Okay? It's a question of the dose. It's a question of how much you get. That's the problem. When problems come in. All right. I think I now have, after this one, a video clip here.
I want to nuke your food, expose it to high levels of ionized rays. Why? Because of food poisoning.
1 person is dead and 50 others are sick from an outbreak of E. coli.
Danger on your dinner plate. The Centers for Disease Control say, on average, more than 1 million Americans are poisoned every week by something they ate.
Oh my God, I gotta go.
Movies, TV make light of it.
I wouldn't go in there if I were you. It's not pleasant.
I can't make it to the other one.
But food poisoning kills about 5,000 Americans every year.
Oh, look out. I'm coming in.
You live next door to the porcelain god for 24 hours.
You may think you had the stomach flu, but much of the time,
You've had food poisoning.
wonder about that chicken. Rainer Mueller knows about the danger of food poisoning because years ago it happened to his son.
My son ate a hamburger.
Emily.
Got sick. And within 10 days was dead. 13 years old. Never a chance to do anything. He was a captain of the soccer team. He was a quality straight-A student. He was a great kid.
Mueller joined a group called STOP, which lobbies for cleaner food, but then he discovered
It's impossible to get food completely clean, especially if the bacteria are inside the food. So you can scrub the outside all you want. You get it clean, but you won't get it safe.
well, there's one way to make food safe: irradiate it. Irradiation moves food through a stream of ionized energy, like X-raying it, to kill bacteria. This isn't a new experimental idea. Astronauts have eaten irradiated food for years. That way NASA doesn't have to worry about them getting sick. Omaha Steaks, the gourmet mail-order meat company, irradiates all its hamburger meat. In fact, meat that's not irradiated should come with a danger warning label, says Omaha Steaks president Bruce Simon. Because no matter how carefully anyone disinfects the plant, they can never kill all the bacteria.
Our plants are cleaner than any emergency room I've ever been in. But it only takes 4 cells to make a person sick. At least with this process, I know that I can kill those cells. The salmonella scare is growing tonight.
So, with so much foodborne illness, why doesn't America irradiate more food? Because radiation scares people, partly because of Hollywood fantasy.
Everyone I
Sorry,
touch
before.
is poison.
You hear irradiation and you think nuclear energy and you think meltdowns,
Ruth Kava works for the American Council on Science and Health.
Chernobyl, 3 Mile Island, all those, and yet it's nothing like that.
But years ago, small environmental groups held anti-irradiation protests.
Irradiation is unnecessary, not needed.
They were very good at getting
There's 2
noticed
reasons.
and at getting other people to worry.
Stop irradiation.
One protest group is Food and Water Watch. Its director recently wrote Zapped, Irradiation and the Death of Food. She claims irradiation can cause
Cancer, premature death, lower body weight.
her organization cites impressive-sounding statistics to back her claims. But when we looked at one study, we saw it said no adverse effects. No adverse effects on survival or body weight.
Well, there's a large body of evidence that shows that lab animals experience these problems.
The author of another study she cites wrote back saying, your statements are a collection of half-truths, misunderstandings, and misinterpretations.
The author of the study works for a facility that gets government money to basically promote irradiation.
So the author of the study doesn't understand what his own study shows? You're scaring people stupid about something that would save lives.
What my organization does is informs people so that they can make their own decisions about the food that they eat.
The scaremongers also say irradiation destroys the quality of the food.
But you can't really irradiate a fruit or a vegetable enough to kill the bacteria unless you want it to turn into mush. It's been described as smelling like singed hair, tasting like wet dog.
That is nothing but lies, say irradiation companies, and they irradiate
How many
all
people
these
eat wet
foods.
dogs? I
They
prefer
look
my
like
dogs
that, and
dry.
They don't smell like singed hair or taste like wet dog. Tastes good to me. We have some irradiated papaya here. You want to taste it, see if you can tell the difference?
No, I'm not interested.
We offered both types of papaya to lots of people, and many preferred the irradiated one.
That's much better. That one's a lot sweeter, I'd say.
It may taste good. It might prevent millions of cases of food poisoning. All these major organizations, staffed by real scientists, say it would save lives. But scare groups like this have been so effective that today just a fraction of 1% of beef and poultry is irradiated.
We should be getting rid of the unnecessary causes of death that are easy to take care of. Food irradiation could help do that.
Next, getting hurt